Thanks. Hi, and I think my people cheated and used ChatGPT to generate that bio. So I was just joking, half joking, that the title of this presentation is a little bit off. This is not just a next generation EAS. This is next generation emergency information across radio and TV. Very different ecosystem that's evolving right now. And this is going to be a very far-flung discussion. It's going to wrap in a lot of acronyms, a lot of different agencies, a lot of different groups, and hopefully I can do just a little bit of justice to the topic. Emergency information, or EAS, is not a standalone. The questions, the challenges, the issues surrounding EAS are part and parcel of the bigger question of where are all the eyeballs, where are all the eardrums going? And the answer increasingly is streaming, of course. So the question we're raising is, how does broadcast remain relevant? What is the value added for broadcasting in an increasingly internet and streaming-based world? And that really comes down to content. It's all about the content, local, compelling content. And the hook I want to remind you guys, and if you're engineering, to remind your program managers, your general managers, is that these annoying EAS messages, this annoying emergency information content is content. It is content, and industry is looking at different ways, new ways, novel ways of presenting that information to become a value-added proposition. Again, there is no content that's more local, more compelling, or value-added to your audience than emergency information, targeted emergency information. Hulu's not providing it. Google TV is not providing it. You heard it this morning in the FCC presentation. They'll take it off, he wanted to talk about that offline. Clearly, the regulator is constrained in getting streaming to carry emergency messaging. And when it comes to life and death issues, and I'm clearly thinking about what happened with this massive storm event just a few days ago, streaming is not the answer. It's not part of the equation, at least right now, and this is where broadcast TV and radio really still has its edge. So today's topics, I'm going to try to squeeze a lot of slides into 20 minutes here, but we're going to cover NextGenTV and advanced emergency information, a new app service. We're going to cover some work that several groups are working on with symbology, with emergency alerting. We'll talk about advanced ATSC service and how these mesh into this whole urgent information space, including data casting and something new called broadcast positioning system that NAB Pilot has really been advancing. And finally, let me get this, the big question of virtualization, which has appeared on the FCC's radar. NAB has made a couple of filings on this, and as an EAS manufacturer, we want to take this head on. So let's talk about NextGenTV and advanced emergency alerting. And what I'd like to do is make this interactive. If you've got questions, if you want, I'm going to condense a lot of information. So if you have questions, raise your hand. I'll address it as best as I can. I will admit, forcefully, I am not an engineer. I'm not a subject matter expert on the engineering side. I work on the policy, the regulatory side, as well as the standard side of the industry. NextGenTV has a variety of different ways of delivering emergency alerting. One is EAS, and to make this really easy, EAS remains the same in ATSC 3 as it does in ATSC 1. Just as EAS remains the same in HD radio as it does in traditional radio or conventional radio, EAS remains the same. The same equipment requirements, the same display requirements, the same reporting requirements, like our beloved ETRS Form 1. NextGenTV, however, can enhance EAS with elements like alternative audio tracks, i.e. assistive audio for audiences that require it, or an emergency audio track, an E-track. So right now, if an emergency alert comes over and the FCC wants it eventually put into 13 languages, well, that can be done in ATSC 3.0. You can have multiple language tracks in ATSC 3.0, and some EAS devices, or frankly specifically ours, can output those languages over all those different paths. Is it easy? Is it cheap? Let's set that aside for the second, because that's our rebuttal to the FCC. It's, miracle solutions are not exactly not always the most cost effective, but it can be done. The emergency audio track also, in effect, replaces the SAP channel. So right now, with emergency information that's not EAS, you're required under the FCC regulations. If you display emergency information that's not EAS, you have to put an oral version of that into a SAP channel. 3 beeps in the main audio, and then insert the voice equivalent of the text display in the SAP channel. Well, ATSC 3 has emergency audio track that handles that, an E-track, and it'll be, in principle, as simple as flipping a button to get onto that E-track and then flip back. That E-track can also be served in multiple languages. So the bottom line here is that accessibility is greatly enhanced with ATSC 3, and even with legacy EAS, a lot more can be done. That's the boring part of the presentation. Where things start to get fun, get interesting, is advanced emergency information. Advanced emergency information is a data service provided by ATSC 3.0 that enhances and goes beyond broadcast interrupt alerts, or EAS. It goes beyond it in a number of ways. It goes beyond it in terms of the types of information can be carried, the limitation of being text only, the limitation of being one language only. AEI is a data service. It activates an application on a next-gen receiver. To date, most of the consumer electronics industry has shied away from putting AEI support directly on the, I think Dave already mentioned some hundred thousands of sets out there. 14 million. Those ATSC 3 enabled sets would be served by a broadcast application, either on the TV set or the set-top box receiver. So either the $500+ set TV, which hopefully go down, or a $150 TV receiver that would generate the broadcast application or serve the broadcast application. The broadcast application has a lot of cool functionality. Let's talk about the basic emergency alerting part. The emergency information can be displayed on the app, including audio and multimedia. So if there's an alert, you get a pop-up, and I'm going to be ambiguous why I don't have a picture of it, and that's kind of a punchline, but you'll be prompted to either, the alert will either be in your face, like a traditional ES for an urgent alert, or a slight icon or prompt to click here for more information. It'll allow the audience to subscribe, essentially, to opt into the type of urgent information they want to see, using selectable preferences such as language as location. Location at this point would probably be zip code, but by other technologies we're looking at going to a specific polygon or specific lat-long locations on a receiver, and allow more specific targeting of messaging. Note I said messaging, not alerting. Messaging by location, urgency, or type of message. Sounds cool. Why is this value added? Well, if it's in your broadcast app, there's a real possibility of serving targeted advertising. And yeah, we're kind of commercializing emergency messaging, but instead of being an intrusive EAS crawl, alerts from the government can be repurposed to AEI, and with AEI you could be serving targeted advertising as making alerting or urgent information a revenue center. Case in point, a tornado warning. Seconds to respond, you're probably going to display that as EAS. Maybe EAS plus A, but that banner is going to go up there if it's a tsunami, probably not going to happen in Ohio, but a tsunami or an earthquake or an evacuation notice. If it's an evacuation notice, if you have a newsroom or you're getting other information, you may follow that up with an AEI message with a whole lot of instruction on where to evacuate. Evacuation zones, evacuation maps, even evacuation video. If you've got an Amber Alert, or the new missing endangered person alert, or Blue Alert, we're hearing, as a manufacturer, obviously we're hearing a lot of concern that, oh my goodness, now we're going to get an MEP EAS alert every 15 minutes. Well, this is a great way of serving that message. Instead of through EAS, make it an optional message on AEI, and you can opt in, click, okay, so I'm interested. I can see the incident, and it's relevant to me. I want to go beyond this and kind of take a look at or reference news and public information. School closings. How many of us love seeing the never-ending or providing the never-ending banner of schools going across the bottom of the screen? Well, this would be another way of serving that type of content. I care, I have kids in school, I see an icon, school closings, click in, I can scroll through the list. I don't have kids, I don't like kids, I don't want that banner, opt out. Doesn't affect you. Just very simple ways of serving urgent information. But again, this is the stuff that streaming can't, won't, I was going to say don't, doesn't fit, but can't or won't provide. This is the kind of edge that broadcast TV and radio can still beat streaming in a very compelling manner. So again, AEI is not just for alerting. It's for all manner of urgent communication, urgent community information. Either come from you as a station, from authorities, whether that's a school district or emergency manager, or from third-party services. Sources like the Weather Channel, Weather Company, if you're using them. That information can be exported from Weather Channel Max into AEI. More information, expanded content, multimedia, bulletins, weather. Weather watches. I mean, there's a tremendous amount of alert content, no weather content that just falls on the floor. It's received by EAS box. You as broadcasters don't even see it. That's stuff that you could use for your consumers in a different form factor. EAS is not the right form factor for probably 99% of the current alerts that are going out there. Here's another challenge. WIA. Increasingly, emergency managers are no longer relying on broadcast for emergency alerts. That's not good for the public, and that's not good for broadcasting. It calls into question the relevancy of broadcasting. The ability to aggregate WIA alerts, and this is something we can do, aggregate WIA alerts and serve them over advanced emergency information. All of a sudden, my counties, Fairfax County, Loudoun County, Arlington County, Northern Virginia, they don't use EAS at all, at all. It's all on, I was going to point my phone wherever I left it, it's all over WIA. I have 5 cell phones in my house, all in the same carrier, all the same model of phone. Only one of those phones do not get any of those alerts. Happens to be mine, great. My 4 kids get the alerts, but I don't. There's a ghost in the machine with WIA. People don't like to talk about it, but here are, I said I'm not an engineer, but I'm reasonably competent. The devices are configured the same. They were bought on the same day, yet 1 out of 5 does not get WIA alerts. Why? Wouldn't it be good to have a backup, like broadcast, that can get that WIA alert into your medium and display it on air in some form factor? Let me keep going here. So the information space for advanced emergency information is everything, basically everything up to and including EAS, but not generalized news information. So if it's not targeted, if it's not urgent, it shouldn't be on AEI. If it is, it should be given real consideration to whether it's, and I'll show you the architecture in a second, exported directly from, say, the DAS deck, our system, into the low-level service AEI feed, or from third-party services. So that's the scope of it. You're targeting people. You're reaching out. Yeah, you still want them to go to your 6 o'clock news. Yeah, you could tie in that alert, that AEI notice to say, for more information, go to, tune in at 6 o'clock. Or within AEI, there's also a facility for a live stream. You can, with the AEI alert pop-up, you can have a window with a live stream of the station's news programming. So several things going on once on your television. Your television is no longer looking like a television. It's looking a lot like a big old smartphone. And you've got several apps running. You may have your main programming on screen, but the AEA pops up and serves the news, the breaking news, if you will, video at the same time. Is this all theoretical? No. We are doing the content side, have been for a while. Broadcasters like Sinclair and others have been pioneering the application side. I know of at least one system integrator who's out in the hallway right this hall who's also looking at potentially an app for industry. So this is not hypothetical. This part is real, very real. If I can get the next slide. Let's see. So here's the overall meshed architecture. Now here's the good news. When I talk to the FCC about this, when I talk to NAB and broadcasters, the good news is that if you're doing an ATSC 3 migration, a huge chunk of this is already in your station or part of your normal plans. Whether it's, does this have a laser pointer? No. Most TV stations have one of these boxes already. Guess what? Seamless migration. EAS remains the same, and adds on a license to enable the emergent processing in ATSC 3.0. EAS insertion remains the same. Jing just left, but I was going to give a shout out. We're working with Nautel. Don't even need a character generator. We've got a Nautel XOS. Well, excuse me, Harmonic XOS. Okay, I'm ahead of myself. Harmonic XOS, EAS net out to the Harmonic, insertion of the video call for EAS. Out this way to your favorite flavor of middleware, Triveni, BitTap, I'm forgetting all the names, Enensys, those are the big guys. For LS insertion, out over the gateway and over the air. The other thing that makes this interesting, even though I've been knocking streaming, is serving the same urgent content over your own web presence, mobile presence, over-the-top presence from your station. So this is yet another way of serving the alerts out over the air. Again, not hypothetical. I'll scoop myself with the next slide. We already put this in the FEMA laboratory. So FEMA is the Thermal Emergency IPAWS. It's taken over. Has become very, very interested in ATSC 3.0. We put an end-to-end stack, wearing a couple of different hats. Envisa and ATSC collaborated. These are some of the companies involved. Also PBS North Carolina and WRAL Television, both out of North Carolina, collaborated to put in an end-to-end system, data casting several receivers. There are a couple I didn't mention there, including VBox and Zinwell for their receivers. We also have BitRouter and Veil receivers. And I'll make a quick comment for Dave. The DRM challenge. Those 4 set-top box manufacturers, they're the guys with the DRM challenge because the costs of DRM seem to be a major complaint for them. I'm not going to comment that that's not at my wheelhouse, but while the major TV set manufacturers are supporting DRM, the challenge for these smaller $100 set-top boxes is apparently something that needs to be wrestled with. So this is the system that is, whoops. Somehow okay. So why am I mentioning the FEMA project? Well, one, it's a proof of performance. It's real. The government's using it. The government's evaluating it. This is not a plug fest. This is a robust system for the government to, frankly, try to use, abuse, and break. It's enhanced EAS and ATSC 3.0. I'll talk to you about what that means in a second. The advanced emergency information, but also something we're going to add in there is data casting, data broadcasting alerts. The question that FEMA is examining is how can ATSC 3 support enhanced public alerting? How can ATSC 3 be part of this world of multimedia alerts and streaming? And one thing we're working, collaborating with FEMA on, that we joined as of November, FEMA is joining the ATSC implementation team that I'm co-chairing, and we'll be starting to work on developing a common look and feel guidance for emergency warning messages, at least the ones that originate from the government. This is something even sorely lacking in EAS, but the government's getting involved in a very friendly way. This is actually one of the best conversations I've had with best collaborations with government I've ever had. Collaborating with FEMA in developing industry-wide guidance on what the common look and feel should look like for these types of alerts over NextGenTV. If you're not a member of ATSC, well, you should join. If you're not a member of the ATSC implementation team, especially if you're a broadcaster, this is an open forum. Join ATSC, join the implementation team, be part of this discussion if this is an interest area of yours. Part of the next-gen display of alerts and advanced emergency information, and part of the work we'll be doing with FEMA is symbology. And Visa, boy, this is going to be, I should have had a slide on all the players, if you look like an NFL diagram. And Visa, the Next Gen Video Information Systems Alliance, put together a recommended practice on symbology for emergency alerts with the goal of making alerts more accessible to audiences, regardless of language, alerts, or culture. What we came up with is an integrated display symbology, VIDS, which is based on FEMA's symbology. FEMA's symbology is based on something called NAPSG, the National Alliance for Public Safety GIS. It actually hurts to even explain what that acronym. But we've taken the FEMA symbology, simplified it, tried to make it more broadcast ready, and that means taking some of the more ambiguous symbols and cleaning them up, but also adding in the symbol sets for event types that NAPSG and FEMA didn't cover. Adding in, for example, a special symbol for an EAN or a National Periodic Test. Adding color schema for alerts, where red is an actual alert, yellow is a warning, and you can see the double underlining, and blue tones for informative messages, and then we've got green for a simple test message. These are all washed by accessibility groups or reviewed by accessibility groups. This is nowhere near done, because FEMA also at the same time has apparently been working with the SUNY Albany, State University of New York at Albany, to do, and they want to get involved in doing a common look and feel. So this symbology set, I should also say, on WIA, the ATSC, the standards group for cell phones, is also looking at symbology. My request to FEMA has been to get all these standards bodies together, coordinate our efforts between ATSC, NVISA, ATSC, SUNY Albany, accessibility groups, advance with a common set of symbology across EAS, integrating symbology in EAS, integrating the same set of symbology in advanced emergency information, same set of symbology on cell phones for WIA, and over the top, and eventually streaming. This is taking some traction. Right now, there are about a dozen broadcasts in the U.S. that have actually have implemented the symbology. They're working through the Kai TV product set, which is adopted the symbology. We're hoping other manufacturers will also adopt the symbology in their character generator sets. We're not asking the FCC to mandate it or even necessarily comment on it. We just want them to know this type of approach exists and could be a workaround for multilingual alerting. That is, if your primary language is English in EAS, and while you could do a lot more in AEI, that symbol, that internationally known symbol, is enough to get your attention, especially for those of us looking at TV out of the corner of our eye or in a cell phone, regardless of your language. There is a hurricane. There is a tornado. Tornadoes are really known. There is tsunami. That's enough, usually, to get somebody's attention. So I've been talking about TV. Let's talk about radio. So here's something we did at the NAB. In partnership with Telos Alliance and Nautel, we implemented something called EAS at the Edge. One of the byproducts was we found out we could integrate symbology into HC radio. Here it is on the BMW motorcycle, which they wouldn't give me, but here it is on the BMW motorcycle at the NAB. I also have several other radio sets with this symbology being integrated. Very simple. This may seem overly simplistic, but here we are, years after EAS, years after HD radio. We finally got around to integrating it. I think these simple adaptations are, again, a major value added for consumers, major value added for the public. Let me blast through data casting for a second. So we've been talking about a B2C model so far, the broadcaster to the consumer. I want to talk for a moment about the broadcaster to the broadcaster. Something we built in Ohio years ago for datacast relay of IPAWS messaging from station to station. This disaster in western North Carolina and other states, again, brings us to the forefront of my mind that if IPAWS is internet dependent, which it is, when there's a major weather event, or in some cases even a minor weather event, or in some cases a local broadcaster forgets to pay their internet bill, and it's happened, IPAWS is done. There's no more connectivity to IPAWS. Yes, you can still get broadcast relay, but if your emergency manager is fixated on WIA and sends in the CAT message to IPAWS, they're not using the local EAS relay, they're using IPAWS, and this is happening increasingly. So our argument is that while the landline internet can be extraordinarily fragile in cases, we can improve or enhance IPAWS dissemination by datacasting IP content. Again, not a novel concept. I was part of a project with FEMA a decade ago or more. Dave Carwile was here. He was part of that back in 2004, 2005 when it started. That project didn't take off, but the concept still remains that datacasting provide a robust broadcast broadband data pipe, basically mimicking satellite connectivity on a terrestrial basis. Broadcasting data to a wide area from, for example, your ATSC 3 station in Ohio. This would be one of your public broadcasters. Broadcasting the IPAWS cap to endpoints at cable head ends. These endpoints are feeding the cap feed within the station environment to whatever flavor EAS unit you have, whether it's Sage or Gorman Redlick or whatever. The DASDAC has this integrated with internally, but it's a very simple, robust architecture. Dave, how long has it been operating in Ohio?
We went on the Ohio system went on December 2016. LP to LP the existing EAS structure.
Okay, so for the recording, been operating nonstop since 2016, 24/7, 365, transmitting IPAWS alerts over the air, State Fiber Ring to, I should put up this slide, from station to station, to every LP1, LP2, and LP3 in Ohio. Others are welcome to join in as well by an ATSC1 data receiver into an IPAWS emulator or an ATSC1 receiver directly into a DASDEC. What does this mean for ATSC3? Well, a lot better in building penetration, potentially much cheaper and much more reliable data receivers, and we're looking at one to potentially be integrated within the DASDEC. It also means non-proprietary. One of the challenges with ATSC1 and one of the challenges FEMA had with that project I mentioned 10 years ago is that it requires ATSC1 requires proprietary datacast clients. Well, in ATSC3, it's all IP from ground up. No more datacast clients. It's a straight transmission over the air into a station's network or into the station's ATSC3 receiver. So this is something, if you're a public broadcaster, I would really strongly urge you, suggest that you take a look at this type of relay mechanism as something that could be folded into the CPB grants for Next Gen Public Warning. Because frankly, this is exactly what FEMA is looking at. They're looking at ways they're finally looking at ways with a change of management at the agency to look at ways of making dissemination more robust, more redundant, to just have it all over the internet. Satellite dishes are expensive as heck. Can you imagine the cost for somebody to operate and maintain 33,000 EAS participants, 33,000 satellite downlinks plus other entities? I think this is a really compelling proposition, whether it's public broadcasters or in the future a mesh network of all broadcasters. It's a really compelling reason why state, federal agencies, legislatures should invest themselves in next-gen television broadcasting. Sorry, mixing a little politics and advocacy with technology here. I also want to talk about something, and this is not quite baked yet, but the ATSC, this broadcast positioning system. It's getting to me now, all these were acronyms. This is a system and method of estimating time position using NextGenTV broadcast symbols. I'm not going to get into the inside the Beltway discussions about GPS threats, GPS spoofing and outages. It's a real threat. DoD's looking at, DoD, the Department of Defense is looking at this. The White House Office of Science and Technology is looking at this. Are there other ways of getting GPS data, whether it's time or time and location sync out into the field, into consumers or into entities that require that information? NAB and its members think, yeah, NextGenTV could provide this type of broadcast positioning, an independent, standalone network providing position, navigation, and timing capabilities, even better than the cell phones can. One tower can provide accurate time at a known position 95% of the time. 4 TV towers, I think this can be done with as few as 3, but 4 TV towers can provide time and position estimation with actually I got that wrong, to an average accuracy of 6.2% of a mile. 6.2% of a mile. The FCC requires WEA to target within 1/10 of a mile, or 10% of a mile. So the potential is there for BPS, for ATSC3, to provide geo-targeting with greater accuracy than even WEA. Fold this back to the EAS discussion, or the Advanced Emergency Alerting discussion. If stations start doing BPS, if they do, then you could target consumer receivers with extraordinary accuracy to feed alerts, targeted advertising, other features much more narrowly to your consumer base, much more narrowly than, say, even streaming can. Here's my analogy. Why is streaming bad for alerting? I can go through 100 different reasons, but one, I'll use my home analogy. I live in Fairfax County, Virginia. Welcome to stop by if you're in the neighborhood. I am on the border of Loudoun County. When I get any notifications targeted to my IP address, it's hooked to Loudoun County, not Fairfax County, or Montgomery County, Maryland, which is clear across a river in a different state. So targeting by IP address is, by definition, faulty. That's one of the legit reasons why streamers saying, unless the consumer can enter their address on a static basis, put in their zip code or wherever they are, geo-targeting doesn't work in a streaming environment, or can't be relied on. With BPS could be a major element in either enhancing streaming or providing targeted alerting or information on a standalone basis. So again, BPS is still being developed, but we're looking at a potential opportunity to deliver GPS independent time and position, detect GPS spoofing, and provide GPS BPS hybrid location for businesses, consumers, logistics companies, and even the government, first responder agencies. I think there's a powerful use case. Now, coming down around the bend now. We'll talk a little about radio. How many of you guys are in the radio industry as opposed to TV? All right, I'll really target this one towards you guys then. These challenges are really not new, but audio IP and virtualization. Virtualization has been touted as opening new possibilities that might provide cost savings and new types of functionality. We're going to challenge that. Virtualization has its limits. Not every use case is a good idea or even possible to be virtualized, especially when it bumps into certain regulatory, security, and operational considerations, and EAS is exactly that type of maelstrom. A lot of the station chain can be virtualized, but there's a lot within the core of EAS that can't or shouldn't be virtualized. So we're here to talk about a hybrid approach. In a partnership between Digital Alert Systems, Nautel, and Telos, we came out with a service, a concept called EAS at the Edge, and it represents hybrid virtualization. It combines the elements of hardware and virtualization to simplify EAS from reception to playback. The key architecture elements are capturing EAS transmission directly from over-the-air sources, putting critical processing where it needs to be, at the point of reception, at the edge, and applying the decode logic and filtering our algorithms to bring that data, AoIP data, to target endpoints for back to target endpoints for distribution. So 3 elements in EAS at the edge: input, routing, and output. Again, we're talking about AoIP, not legacy audio. The EAS message is processed on the input side. Forwarded messages contain both AoIP and routing info for the targeted output, and messages are received at the other edge of the network and transmitted. So bottom line is, as a station is virtualizing almost all of its stack, the EAS encoder-decoder, specifically the DAS-DEC, can enable EAS in that type of environment without causing a whole herd of operational issues, rule changes from the FCC, and frankly, cost increases. I'm going to say this bluntly. If anybody thinks that virtualized software is going to be cheaper than just having a box, think again. I don't know of any industry where virtualized software has not ended up more expensive on a multi-year basis than just a server. Look at Microsoft. The example was given this morning, Microsoft. If you want a virtualized system, you're just going to have some form of support, monitoring, help desk, 24/7, 365, and you're going to want 5 nines of reliability. That's going to come at cost, whoever does it. Let's see, where am I with this? Here's a bit about the expanded signal flow here, where you can see this should be the DAS-DEC by A67 LiveWire routing to the LiveWire device and out over the air. Pretty simple architecture. Some consideration we're looking at addressing our PPM code, the PPM meter, and the ability to eliminate double encoding risk with AoIP. That resolves a major challenge that other proponents of pure virtualization hadn't, I think, fully considered. Addressing the PPM encoding bypass. By the way, if you want a copy of these slides, after please give me your card. I'd be happy to email them to you. Also adding metadata as additional value by routing, for example, the AS67 LiveWire routing disable preset controls out to every element of the chain, including RDS encoding at the end. So someone at the same time as this is giving a presentation on RDS encoding in small markets. Well, this is a simple way of handling that by directly interfacing the DAS-DEC by EASnet to the RDS encoder in addition to the rest of the stack. And most of the major manufacturers, Innovonics, etc., are supporting EASnet, have been supporting it for years. Let's get really simple. EAS at the edge with the Omnia 9, all these functions that are within the Omnia 9. Here's your virtualization. The physical element, which you're going to need anyway. If you virtualize, you're still going to need 3 radio receivers. You're going to need switching. And I'm pretty sure that's not going to be a whole lot more than the cost of the baseline EAS encoder-decoder to put all those elements together. Already exists in the EAS unit, feeding the rest of the virtual chain within the Omnia 9. Equal time to Nautel, same proposition. LiveWire, control, EASnet, interoperability with the Nautel TV2 transmitter. I encourage you to talk to both TELUS and Nautel here at the show. They can tell you more authoritatively than I can about the technical details, but we demonstrated this at NAB live. We had this interfacing with a good number of receivers. This is a way, quite bluntly, to address the challenge of station virtualization with an approach that keeps all the FCC's and FEMA's concerns intact, without having to rewrite Part 11, without having to enter all sorts of risks for software of unknown provenance, of errors. The idea of virtualization and putting EAS software on somebody's server, potentially unknown, is just unworkable. We can't warrant its performance. We will not warrant the performance. When I say warrant, I mean we can't guarantee the performance of EAS if it's going into a physical environment that we don't know. I'm not going to say we don't control, we don't know. We can't warrant performance if the EAS software is within somebody else's stack that we have to go through to do updates or maintenance. it's a walled garden. We can't update our own or manage our own systems. So I'm hitting that proposition hard because there's a simpler answer that gets to the entire virtualization area. I'm sure we're running out of time, right? So let me hit with a couple of last points here. EASnet is an edge-to-edge virtualized solution that's been realized. It meets the key benefits of regulatory compliance, offline capabilities, bandwidth optimization, reduced network dependency, enhanced security and privacy. The NAB's own filings said they're concerned about broadcasters being able to meet the FCC's comments, desires on cybersecurity. Well, that's kind of scary if on the one hand you're saying some broadcasters may not be able to meet the FCC's goals on cybersecurity, at the same time you want to go into a fully virtualized environment. So that I probably need to cut off here with the last comment that the one thing that is also being adopted is a service called Halo, and that provides this is the part we did virtualize, remote monitoring and managing of all EAS in a virtualized environment. The ability to aggregate real-time health beats, status, logs, and to configure them remotely from a single desktop. That part is virtualized. So while the physical element still resides at the station, all the management, operation, and in the near future software updating can happen from a single point. So if you've got 3 stations, if you've got 50 stations, this will radically reduce your burdens for ETRS test reporting, configuration management, and health management of EAS, especially in a virtualized environment. I feel people breathing down my neck, so I will just say what will be happening next. I'll leave it by saying a lot will be happening next. Look and feel guidance coming between industry and government, more development in ATSC 3 on advanced emergency information, more development with an HD radio on geotargeting and enhanced message display, addressing this challenge of virtualization in a managed way. And my personal initiative for 2026 is beginning to integrate targeted advertising or targeted information with advanced emergency information and make this a service that makes sense from both a public safety but also an economic sense for stations. That is probably too much for one session. Sorry, I jammed 2 hours. I literally jammed an SBE webinar into 20 minutes. So go to SBE, ask for your education credits, and I'm open for questions here, or if we're out of time, outside.